All right, this is the continuing notes on 5-6 inverse trig functions, and we're doing derivatives, and we came up with some shortcuts to be able to figure out the derivatives of these inverses. And I have 1, 2, 3, 4 listed, and I have 5 problems down here that involve them, and then I think there are a couple more on the notes that I'll be talking about also. So if I look at arctan here, I need to identify g of x and g prime of x. So if I look in here, I can see that inside the arctangent, g of x has been defined to be 2x. So its derivative is going to be 2. So dy dx, the derivative, is going to be 2 over 1 plus 2x, that squared, which can be written as 2 over 1 plus 4x squared. And I'm done with that problem. You can see it's a lot quicker than using the triangles, though the triangles will get you exactly there also. So here, g of x is defined to be 3x. Means g prime of x is equal to 3. And sine is right here. That says dy dx. Excuse me, arc sine is right up there. That's going to be 3 over the square root of 1 minus g of x squared. Well, g of x is 3x, so g of x squared is 3x times 3x, which is 9x squared. And I am now done with that problem. Over here, g of x has been defined as the square root of x, which is the same as x to the 1/2 power. So g prime of x is going to be 1/2 x to the negative 1/2 power. Okay, that's just using the power rule. And I'm talking about cosine, and cosine's right here. So I'm going to have dy dx is equal to the negative derivative, so I'm going to have a negative 1/2 x to the negative 1/2, because that's negative g prime of x, over the square root of 1 minus, now what do I get when I square this? What do I get when I take x to the 1/2 and square it? Well, I can multiply those exponents if I choose, and I'm just going to get x. So I can simplify this a little bit. A negative 1/2 can be written as a negative 1. Here's my 2, so there's a negative 1/2. X is to the negative 1/2 power, so I'm going to write that as the square root of x, means it's in the denominator, times the square root of 1 minus x. Now since both of these are in the radical, I can multiply through. And my final answer is going to be a negative 1 over 2 times the square root of x times 1 is x, minus x times x, which is x squared. And that's my final answer. All right. Let's look at this particular one. So that my g of x is equal to e to the x. So g prime of x is 2e to the 2x. So again, this is, arc secant, and arc secant's over here, so I have dy dx. And g prime is going to be on top, so it's 2e the 2x over the absolute value of e to the 2x, though e to the 2x is always positive, so I actually could drop those absolute value symbols, which I will in a second, times the square root of e to the 2x squared minus 1. So this is going to be, let me rewrite dy dx down here since I have a little bit of room. 2e to the 2x. Here I have e to the 2x. That's going to simplify. And here I have the square root of e. Well, I'm going to multiply those exponents, and I got 2x times 2. It's hard to see the 2x, but it's going to be 4x minus 1. So it's 2 over square root of e to the 4x minus 1. All right, here's my last one. See if I can create some room in here to help me out. And what I have here is, since I'm multiplying, I got just plain old x times the arctangent, so I'm going to have to use the product rule. So just to review the product rule, I got dy dx equals x times the derivative of the arctan, which I will do, plus the arctan, the square root of x, times the derivative of that x, which is 1. Okay, so I've got 1, 2, 3 of the 4 parts done. I just have to figure out this. And again, I'm going to use up here, I'm going to have the derivative. So what's the derivative of the square root of x? We kind of already answered that. It's going to be 1/2 x to the negative 1/2. And down here it's going to be 1 plus g of x, right? G of x was equal to the square root of x. G prime of x is equal to 1/2 x to the negative 1/2. That's where I get that. So when I square g of x, I'll get x. All right, so let me just arrange this. So dy dx, I'll rewrite that, is equal to, well, what's going to be left here? I'm going to have x on top. And I have a 2 here on the bottom, because that's 1x. And I have x to the 1/2 times 1 plus x. Well, this is to the first, so I can subtract these exponents. My final answer is x to the 1/2 in the numerator and 2 times 1 plus x in the denominator. All right, got one more problem. I'm going to clear the screen. And the problem is, again, I'm going to find the derivative. I think it's number, or problem L. Y equals the arc sine of x plus x times the square root of 1 minus x squared. Well, the arc sine, if you recall, the derivative of the arc sine of g of x dx was equal to g prime of x over 1 minus the square root of 1 minus g of x squared. So I'm going to figure out this derivative here first. G of x is equal to x. G prime of x is equal to 1. So dy dx here is going to be 1 over the square root of 1 minus this function squared, x squared. And I'm done with that. So over here I got plus. Now I got the chain rule here. Notice I put the times in there. So it's x times 1/2 times 1 minus x squared to the negative 1/2 times what's in derivative inside, a negative 2x, plus square root of 1 minus x squared. I'm going to times the derivative of x, which is 1. So let me simplify this. dy dx is equal to 1 over the square root of 1 minus x squared plus, well, this half, this is negative, and x times x is x squared, so I have a negative x squared. This has a negative exponent, so down here I have the square root of 1 minus x squared plus, when I multiply this out, I get the square root of 1 minus x squared. Since the denominators are the same, I can combine those. 1 minus x squared, and I'm going to put parentheses around it right to the first power. And down here I'm going to put parentheses around this too. 1 minus x squared to the 1/2 power plus the square root of 1 minus x squared. Well, here the bases are the same. Here are my exponents, so I subtract the exponents. 1 minus a half is a half, and I get the square root 1 minus x squared, because that is 1 minus x squared to the 1/2 power, plus another 1 minus x, the square root of 1 minus x squared. Square root plus a square root is going to be 2 times the square root of 1 minus x squared, and that's my answer.